So we're halfway. And really, I think we're a bit over halfway. We've done 3 tests, okay, but I do think the majority of the course is chapter 1, 2, or 3, so focusing on those calculus stuff. As far as content goes, we'll find both chapter 4 and 5 really short and probably a fair bit easier than calculus was. Okay, some of the stuff in chapter 5 can be a bit challenging, but what we're going to be working on, is chapter 4, and that'll be our next test. It'll probably take us about 2 or 3 weeks. All right, to get through. So it is a bit disjointed as well, this topic. So I've tried to order it in what I think is the most sequential manner, the most logical manner. So I've written that right at the start. That just said we're going to do it in this order. Okay. So today we are going to start with 4A, and you might be thinking, and then tomorrow we'll do 4B, and you won't see a connection between A and B until we get right to 4G. Okay. But we will start with this. And so we've got, let's get straight into it. We've got this y equals 2x plus 1. Sketch the function over the interval 0 being less than x being less than 2. So here's 0, here's 1, here's 2. It's the equation of a line. Okay, it has a y-intercept of positive 1. And as x goes across 1, y goes up 2. It has a slope of 2. Okay, so the coordinates of that point there would be 3. And then we're going across 1 and up 2. The coordinates of that point there would be 5. Fantastic. Okay, so what we're doing in integration, and really integration is part of calculus, okay, but just for simplicity, I'm going to talk about them as separate things. Calculus is going forwards, integration going backwards. So within integration, mainly what we're talking about is finding the area under some curve. Okay, so it might be like, what is the area of this shape here? Now we will do a geometrical argument in a moment, but one way we are going to learn that we can solve this is by using what's called upper and lower rectangles. Okay? So lower rectangles are rectangles that are drawn beneath the curve. So that would be one rectangle, and that would be another rectangle. And if we find the area of both of these rectangles and add it together, it's going to be an approximation of the area under the curve. It's going to be a relatively poor approximation, but it is going to be an approximation. So that's what we're going to start with. Let's find the area of these lower rectangles. Okay? So let's just call it like rectangle A and rectangle B. And we can see that rectangle A has a width of 1 unit and a height of 1 unit. So the area of rectangle A is 1 times 1. Rectangle B has a width of 1 unit and a height of 3. And so here we have like an estimate for the area as 4 units. Okay, is this going to be equal to the area? Is it going to be larger than the actual area, or is it going to be lower than the actual area?
Lower.
Say again?
Lower.
Lower, significantly lower, isn't it? We haven't calculated the area of this part, and we haven't calculated the area of this part, so it's going to be off a fair bit. Okay, then what we're going to do is we're going to calculate the area of the upper rectangles. So upper rectangles are rectangles that are drawn above the curve. Okay, so we're going to have this big one and this big one here. So this is what we call our lower estimate. Our lower estimate is 4. And for our upper estimate, I'm going to use the same labels for triangles there, A and B. In our upper estimate, the area is going to be 1 by 3. And B will be 1 by 5. And our upper estimate here, okay, is it going to be equal to the actual area? Is it going to be lower than the area or above the actual area?
Above.
Yeah, it's going to be significantly larger because you can see we've overestimated the area. We've overestimated it by this triangle here and this triangle. It's too large by that amount, okay? Whereas if we think about our underestimate, it was too small by this amount, wasn't it? So we have an interval, yes, Felice?
When you're doing the upper, is that the whole way from like the bottom of the graph, like from the x-axis up?
Yes, full block.
It's the full triangle to the
It's that full rectangle, yes, absolutely. Yep, you have to consider the whole rectangle. So what we have here then is we have a statement for the area, we have an interval, okay? The actual area lies somewhere between 4 and 8. Okay, the actual area lies somewhere between 4 and 8. So how might we improve the accuracy of this estimate? How could we get a bit closer to the actual area?
Use more rectangles.
Excellent, so let's try that. So let's, I think it says in the next part says make a conjecture. The part following that says, yeah, using 4 rectangles. So we're going to repeat exactly what you've just done, but we're going to use 4 rectangles, both 4 lower and 4 upper. So if we're using 4 rectangles, that means the width of each rectangle is 0.5 units, isn't it? Okay, so the first lower rectangle will be here. The second lower rectangle is going to be here. The third lower rectangle is going to be here. And our fourth lower rectangle. Alright. And but before we go ahead and calculate that, let's have a look. How much error have we eliminated? Okay? So in the first triangle, this whole thing here was our error. We had that much error. Now if we do 4 rectangles, we're eliminating all the error in that part there. Okay, so here we can really see, if we're adding more rectangles, we're going to reduce the amount of error that we have. Okay, so I'll do the lower estimate with you, and then I'd like you to have a go at doing the upper estimate. And I'm just going to do it in one go here. The lower estimate is going to be 0.5. 0.5 is the width, right? So 0.5 is going to be common to every rectangle. I might write it out first and then be clear. So we have 0.5 times 1 plus 0.5 times, when x is 0.5, the y value is 2. When x is 1, the y value is 3. And then when x is 1.5, the y value is 4. So yeah, have a look at this. 0.5 is common to all of them. So we can factorise 0.5 and we could just write it as the sum of the y values. We've got the y value of 1, y value of 2, y value of 3, and y value of 4. So what's that? 3, 6, 10. Okay, that's our lower estimate. Okay, that's our lower estimate using 4 rectangles. We'll get you to have a go at our upper estimates while I bring up something on the computer. Okay, so for our upper estimate, we're going to draw the rectangles from the top point. So that's our first rectangle, here's our second rectangle, here's our third rectangle, and this will be our fourth rectangle. Just bring the computer up. So we should get a 7. Okay, very good. So I'll assume we're sort of done. We did that. We should have 0.5 times. Now all of a sudden, rather than the y value for the first rectangle being 1, the y value for the first rectangle is 2. In fact, one way you could look at it is what's happened is all of the rectangles we did first have been shoved to the left. Okay, so that rectangle is now there, that one's now there, okay, that one's now there, and we've got this new rectangle. All right, that's one way you can look at it. So we're going to have 0.5 times 2 plus 3 plus 4 plus 5. Okay, so that's 0.5 times 14, which is 7. Okay, so now our interval is 5 is less than the area, which is less than 7. So we're more accurate. We've eliminated some error. Okay, and we could repeat this ad infinitum. We could repeat this forever. So let's do that. Let's use 50 rectangles. Okay, between 0 and 2. So this is some software that you guys are going to be using for some of the exercise questions in 4A.2. So that's why I've sent that link to the group. So you're putting the graph here. We're putting the interval here. We're talking about between 0 and 2. How many rectangles we're required to use. And rectangles from the left, you can see that they're below the line. Okay, so they're lower rectangles. And you can see it's a lower estimate because our estimated area is 5.92. And here, it does tell us the actual area. The actual area below the curve is 6. All right? And so you can see, like here we have 2 rectangles. We had an area of 4. When we had 4 rectangles, we had an area of 5. When we used 50 rectangles, we got an area of 5.92. So there's still a bit of error, 0.08 error, but we're getting closer and closer. So the more rectangles we're using, the closer and closer we're going to get. Okay, so with that in mind, what's the next part? Find the solution using a geometric answer. So with a line and some curves, or perhaps circles, we can use a geometric answer to find the solution. So what we have here is we've got 1. This is 2 units across here, and then this point here is 5, isn't it? Okay, so this is a triangle and a rectangle, or a trapezium if you want to be complex about it. But we can divide that up into 2 shapes, and the total area of this shape is the area of the rectangle plus the area of the triangle. So that's going to be the rectangle, 1 times 2, plus the triangle is going to be 0.5 times the base times the height. Alright, so we'll have 2 plus, this is half of 10, is 2 plus 5. What did I do wrong there? 1 plus 2.
Is that height? It's supposed to be 4.
4, thank you. And why is that 4? Because the distance to there is 1. So the whole thing there is 5. That distance is 1, so this distance is 4. Thank you. That was a bit sneaky. So that's going to be 2 plus, 2 plus 2. About 8. 6. 2 plus 4 is 6. Okay, which is what we notice about this as well, and you'll notice this pattern is whenever we're finding the area of a line, it is always going to be halfway between the lower and the upper estimate. Okay, so even if you were to only use 1 rectangle, all right, the actual area is always going to be halfway between the lower and the upper. That is only the case for a straight line. Okay, let's move on to question 2 then. I might spin this around. All right, so what have we noticed so far? The more rectangles we use, the closer our estimate is going to be. So, question 2 says, find the integral from 0 to 2 of x squared. Now, what does that mean? Okay, so this is a link we're going to make in the future. But this means find the area from 0 to 2 under the curve x squared. So if we sketch the function x squared, it's a parabola, looks like that, and we're asked to find the area between 0 and 2. We're asked to find this area here. okay, the area of this shape. Now it's not a straight line, so it's not going to be exactly halfway between the lower and the upper. So we're going to have to use 2 upper and 2 lower rectangles. So firstly, let's go with upper, because they can be less confusing. Now we're solving between 0 and 2. So that's an x value of 2, here's an x value of 1. And our upper rectangles are going to be this rectangle and this rectangle. Now remember, this is the function y equals x squared. Y equals x squared. So that means the y value of this point is 1. 1 squared is 1. And the y value of this point is 2 squared, which is 4. Okay? So then our total area, or our lower estimate, is going to be 1 times 1 plus 1 times 4.
Is that the lower or the upper?
Upper. Thank you, Jimmy. Yeah, we're doing the upper this time first. 1 times 1 plus 1 times 4. So we'll have 1 plus 4. Our upper estimate is 5. Okay, compare that with our lower estimate. The reason I'm doing the lower estimate second is because you're required to draw a rectangle to there, and then this rectangle to there. Okay, so that's 1 and that's 2. What is the height of this rectangle?
0.
0. Okay, so the area of this first rectangle is 0. Then we've got when x is 1, y is 1. So the y coordinate here is 1. And so our lower estimate is 1. The area of this rectangle is 1 times 1. So state an interval for the area under the curve x squared. Well, it'll be 1 less than the area, which is less than 5. Okay, so that is enough to do both 4A1 and 4A2. I remembered historically, okay, lots of people have found, so we're chapter 4A.1, okay. So question 1 should be fine. Question 2, all right, can be a little bit tricky. So we can maybe go through that together if you like. But you will see in question 3 how it says using 10 triangles, 20 triangles. You don't have to do that manually. Okay, obviously that's where you use this sort of software. So I might say, yeah, have a go at question 1, have a go at question 3, and maybe we might do some of question 2 together. Yeah, that's enough to get started.